All right, pre-calc, here it is, the grand finale of Unit 4B. Day 10 is going to be a little continuation of working backwards. So yesterday in our lesson, to recap, we learned what the standard form of an equation looks like for a quadratic and a cubic based on the sum and product of the roots. So for quadratics, we just need the sum of the roots and the product of the roots. So we know that we change the sign of the sum, keep the sign of the product. For cubic polynomials, we know we have this extra term that's involved here. So it's change the sum, keep sum 2, which is the sum of the products 2 at a time. And then we change the sign of the product, and that's what goes at the end of the equation. So based on all that, let's go ahead and see if we can, for practice here, find the equations given these roots. So we have 1, 4 plus or minus 3i, and then we have negative a half, 1, and 2. Okay, so for number 1, if we want to find the equation, this is a cubic polynomial because 4 plus 3i and 4 minus 3i are treated as two different roots. So we're going to find the sum first. The sum would be 1, 4 plus 3i, and 4 minus 3i all added together. So the I parts will cancel as we're kind of used to seeing it now. So 4 plus 4 is 8, plus 1 is 9. Sum is 9. All right, and then from there, if we want to do the sum 2 at a time, it's the sum of the products when taken 2 at a time. So we've got to do 1 times 4 plus 3i, 1 times 4 minus 3i. And then the last one is the conjugate pair, 4 plus 3i times 4 minus 3i. So when you multiply these by 1, you just get 4 plus 3i and then 4 minus 3i. So those are easy. But when I do the conjugate pair, you just have to be a little bit cautious. And I may not always illustrate this, but maybe just for this first one I will. 4 plus 3i and 4 minus 3i, we get a 16 here, a 12i, a negative 12i. Conjugate pairs, you always get those terms to cancel, always. And then minus 9i squared. But oh wait, I squared is negative 1. Negative 9 times negative 1 is 9. 16 and 9 is 25. Remember that when you find the sum 2 at a time or the sum or any of these coefficients, you can never have i's as part of your answer. So if that's happening to you, we gotta go back and check our work. All right, so those I parts cancel when I add these together. 4 plus 4 is 8. 8 and 25 is 33 for the sum 2 at a time. And then finally, the product is all 3 of them at once, which is not a lot of effort at all, considering we know that this product is already 25. So 25 times 1 is 25. And then finally, piecing everything together, remembering that those signs alternate. X cubed, you just kind of keep alone. But then change, keep, change for the signs. So we're going to start by keeping x cubed. Change the sum, minus 9x squared. Keep the sign of the sum 2 at a time, plus 33x. Change the product, minus 25 equals 0. Don't forget about equals 0. It's the difference between a 99 and a 100. I want to see hundreds. Okay, so there's my equation given those 3 roots. Let's go ahead and work down the other column here with roots of negative a half, 1, and 2. To be honest, it seems like this might be the easier example, given that these had complex roots, but sometimes fractions are not always our friends. I hope that's not the case, but sometimes students do struggle when they're adding all these together. And the reason being is when you have to add things with fractions, well, now we have things that, we have to make common denominators. Really try and avoid decimals if you can. I mean, I guess if anything, you can say that this is 3 minus a half. 3 minus a half is 2 and a half, but you're not going to use mixed numbers either. So 3 is really 6 halves. 6 halves minus 1 half is a total of 5 halves. I want to see those as improper fractions. We'll see why in the end that needs to be the case. So the sum 2 at a time, you're going to take negative a half and multiply it by 1. You're going to take negative a half and multiply it by 2. And then the only other pair you can make is 1 times 2. Okay, so negative a half times 1 is just negative a half. Negative a half times 2 is negative 1. 2 times 1 is 2. So when I combine the 2 minus 1, that's a 1, right? And 1 is really the same thing as 2 halves. 2 halves plus negative a half is a total of positive a half for the sum 2 at a time. Okay, so just be careful with those signs there. The fractions, when their denominators are 2, it's not that intimidating. All right, finally for the product, if I do -1/2 times 1 times 2, well, -1/2, if I combine it with the 2 first, that's -1. And -1 times 1 is -1. So we've got the sum 2 at a time, the product. So when I start writing the equation, we're going to keep x cubed, change the sum, -5/2 x squared, keep sum 2 at a time, plus 1/2 x, change the product, plus 1 equals 0. But I'm not going to get too far ahead of myself and box this in quite yet, because this does not have integral coefficients. These have to be integers. Right now, they're fractions. So from here, to fix this such that we don't have denominators with 2 anymore, I'm going to multiply both sides by 2, keeping in mind that's not going to change the side with the 0 on it. But your final answer would be 2x cubed minus 5x squared plus x plus 2 equals 0. Okay, 2x cubed minus 5x squared. This cancels here to make it a 1x, and then plus 2. That is the polynomial that has those roots, but now it has nice integer coefficients. Okay, so that's it. It's some quick practice. We'll do maybe a little bit more with this next time I see you. But we have one more new thing to learn. The last thing we have to learn is the general rule for 4th degree polynomials. Okay. So we know the rule for quadratics. We know the general pattern for cubics now. But what's the general rule look like for 4th degrees? It's really, really similar, but we have one extra term we've got to add on. All right, I'm going to try and squeeze it all in here. You ready? It's x to the 4th. Change the sign of the sum. That now goes next to x cubed. No surprises yet there. Keep the sum 2 at a time. But now that's next to x squared. So we still have this idea with sum of the roots 2 at a time. Change, here's the new coefficient, you ready? The sum of the products 3 at a time. That goes next to x. And now that I'm at the last term, we're alternating signs, right? We keep, change, keep the product and set that equal to 0. So the only thing that's new is since we have an extra term, we have an extra new coefficient called the sum of the products 3 at a time, which I like writing as sum 3 as an abbreviation there. So a lot of this is going to look the same. We'll see how that maybe looks a little bit different, given that the roots are, let's go with -4, -2, 1, and 3. How about a good mix of positives and negatives, but they're all integer values to kind of get ourselves started here. Okay, the sum of the roots, -4, -2, 1, and 3. If I add them all up, let's see, this is 4, so that would actually cancel with the -4 to get a total sum of -2. Okay, sum 2 at a time. We have to pair up roots, take the roots 2 at a time, find their products, and then add those results together. What I'll tell you is that the sum 2 at a time for a 4th degree polynomial, there are 6 combinations of taking the roots 2 at a time when you have 4 roots total. So let's see if we can come up with all 6. It's -4 times -2. Okay, so let's take the first root, pair it with all the others. -4 times 1 and -4 times 3. Okay, I took the first root, paired it with the other 3. Now let's move on to the second root, -2. Pair that with 1, and then pair it up with the 3. So the last pairing that I haven't done yet is just the last 2 roots together, 1 and 3. But this is all 6 combinations. I think it works out nicely that if you take the first root, pair it with these, second root, pair it, third root, one final pair there. All right, so if I multiply all these together, just careful, we get 8, -4, -12, -2, -6, and 3. So we've got to add all of that up. Okay, well, 8 minus 4, that's 4. Minus 12 is -8, -10, -16, and 3 is -13. Okay, so however you best want to combine all those, we get -13 there. All right, let's look at what the sum 3 at a time looks like. This is going to be a little bit new for us. We have to look at roots not 2 at a time, but take 3 roots at a time. So let's say I take the first 3, -4, -2, and 1. By the way, if you want a hint here, there are 4 combinations. If you have 4 roots and you want to choose 3, there's 4 ways to do it. I can do the first 3. I could do 1, 2, the first, second, and fourth, -4, -2, and 3. I could do the first, third, and fourth roots. I could do -4, 1, and 3. All right, so I did these 3. I did these 3. And then I did these 3. The last combination is the last 3 roots of -2, 1, and 3. Okay, so now that I have that, the products there are going across. We've got +8. There's going to be 8 times 3, which is 24, -12, and at the end, -6. So if I combine those, we've got 24 minus 18 is 6, and 8 is, I think, 14. I'm going to double check here. Yeah, that looks like 14 to me. Whew, okay, we're almost there, but we still need the product. We haven't done the product yet. -4 times -2 times 1 times 3. By the way, this is the product of the roots 4 at a time. We never say it that way, the sum of the products 4 at a time. There's only one way to take the roots 4 at a time. And just take all 4. 8 times 1 times 3 is going to be 24. So we've got the sum 2 at a time, sum 3 at a time, product in that order. Here we go. Ready? It's going to be x to the 4th. That's exciting. Change the sum always. So now it's plus 2x cubed. Keep the sum 2 at a time, minus 13x squared. Change the sum 3 at a time, minus 14x. Keep the product plus 24. Don't forget equals 0 because we want a 100, not a 99. Okay, let's do one more of these just to make sure we got the process down. And then we have one little quick thing that we'll, actually maybe we'll do that in the recap tomorrow. That sounds like a good idea. Sometimes I have good ideas. Okay, last one we're going to do is 2, -5, and then 2i. Okay. So given that those are the roots, 2, -5, and 2i, at a really quick glance, it looks like a cubic polynomial, doesn't it? 1, 2, 3 roots. But if you have 2i as a root, you also automatically have -2i. They always come in a conjugate pair. So don't get fooled by something like this, where you just see 2i and you're like, all right, let me do a cubic. It's a 4th degree. Even if the other complex root's not listed, you should write it in and go through the same process. So let's talk about the sum. The sum would be 2, -5, 2i, -2i. Okay, nicely those I parts cancel, which we should see happen. 2 and -5 is -3. Okay, next we need the sum 2 at a time. So that's going to be 2 times -5, 2 times 2i, 2 times -2i. Take the first root, pair it with the other 3. Now move on to the second root, -5. Pair it with 2i, and then pair it with -2i. And the last pairing I can do is the final 2, 2i and -2i. Remember, you'll always have 6 combinations here. So if you count them up and you forgot one, hopefully you can figure out which one it is. All right, 2 times -5 is -10. This is 4i, -4i, -10i, +10i. Look at all those things that are going to cancel. We like this. 2i times -2i is -4i squared. But oh, wait, I squared is -1. -4 times -1 is +4. So be careful about that. But again, the i's cancel, so we get -10 and 4 for a total of -6. To be honest, this is probably even almost a little easier than this one, even though we had these imaginary roots. Look at all that stuff that cancels so nicely. All right, let's talk about the sum 3 at a time. So the sum 3 at a time, let's do the first 3 together, 2, -5, and 2i. Then maybe I'll do 2, -5, and -2i. I can do the first root with these 2 at the end, 2, 2i, and -2i. The final pairing is -5 times both of them. So -5, 2i, and -2i. All right, let's see what all of that comes out to be. 2 times negative 5 is negative 10 times 2 is negative 20i. 2 times negative 5 is negative 10 times negative 2 is positive 20i. Already those cancel, don't they? Negative 20, positive 20. Okay, let's see what we've got here. 2 times, oh wait, 2i times negative 2i, guys. Didn't we do that over here? Isn't that 4? So cheat, use that answer, right? If this is 4, 4 times 2 is 8. And again, here it is again, 2i times negative 2i. We know that that's 4. 4 times negative 5 is negative 20, and negative 20 plus 8 is negative 12. We're almost there. We need the product. The product is all of them at once. 2, negative 5, 2i, and negative 2i. Hey, we already know that's 4. 4 times this, which is negative 10, is negative 40. Sum 2, sum 3. Product. Ready. Here we go. X to the 4th. Change the sum plus 3x cubed. Keep the sum 2 at a time. So minus 6x squared. Change the sum 3 at a time. So plus 12x. Keep the product. Minus 40 equals 0. And we are done. That's it. We have a little bit more to recap with this tomorrow, okay? It's going to be related to this, that if I gave you an equation asking you about what the sum and product of the roots are, but that should actually go really quickly. We'll do a little bit more practice like this, and then that's it, guys. We're pretty much done with the hops unit. I'm a little sad, if I'm being honest. I love this unit. All right, let me know if you have any questions. We'll catch up at the